In this video, I've got this negative temper circuit. I've got a 3-volt peak input sinusoidal wave, a 3-volt peak input. I've got a 100 microfarad capacitor. I've got the parallel combination of a 1N4007 diode and a 100 k-ohm resistor on the output. The frequency is 60 Hertz. On the output side of the circuit, I'm going to get this waveform. The average voltage is minus 3 volts with 0 volts at the top. Now what's happening here is, as the signal goes in, the positive half cycle will be going through the 100 k-ohm resistor. But the negative half cycle will be going through the diode, charging up the capacitor to 3 volts. Now the reason I have this negative 0.6 volts here is because of this diode right here. This particular diode will give you a voltage drop of 0.6 volts as the negative cycle is being sent through the diode. Now what will happen is, because it's dropping voltage of 0.6 volts, if I do not have this negative 0.6 volts here, what will happen is I will end up with a voltage of about 2.4 volts here and 2.4 volts here. So if I don't have this negative 0.6 volts here, what will happen is I will end up with about 2.4 volts here and a minus 2.4 volts here. On the output side, the top of the waveform will be up above 0 volts, approximately 0.6 volts. So in order to bring the voltage back down to where the top of the waveform is sitting right on 0 volts, and to get the full 3 volts of the negative cycle across the capacitor and on the output, you have to put a minus 0.6 volts right here in series with the diode. Now once you have done that, you will have the full 3 volts of the negative peak across the diode, and you will get your full minus 3 volts on the output. So this is why I have the 0.6 volts or the minus 0.6 volts in series with the diode, because this particular diode the 1N4007 is going to give you a voltage of approximately 0.6 volts. Now I'm going to evaluate the RMS voltage of the output. Volts RMS out equals square root 3 volts squared, it's the 3 volts peak, plus 3 volts squared over 2. This 3 volts squared is actually this DC offset right here. So it should be minus 3 volts squared. And when you calculate that, square root 3 squared plus 3 squared divided by 2. That will give you an RMS voltage of 3.67 volts out. And this brings me to the end of the video. Like and share the video. Like and share the video. And thanks for your attention.